The next unit that we're going to do, it's called uniform circular motion. Now, what we have to recognize is that, when you were doing the lab, you were basically spinning something around, and the speed of that object was essentially constant. And that's what it means to be uniform circular motion. We're talking about something moving in a circle at constant speed. So not speeding up, not slowing down, just a steady rate. Now, in terms of the path, if you were watching that object move in a circle, what it was doing was it was covering this path here, maybe going, in this case, we'll have it go clockwise, and it goes all the way around, and it takes a certain amount of time to do that. For us swinging around in a circle, really didn't take all that long, but that time is called the period. So the time for one full rotation or one full cycle, that's called the period. And its symbol is capital T. In addition to that, it's the best measured in seconds. So it's one way to describe how fast something is moving in a circle. Now, what we're going to do is also describe it another way. We can talk about frequency. Frequency is basically a measurement of how often something occurs in a given time period. So what we're going to think about is how many cycles occur in 1 second. Basically, that would be saying something like cycles per second. What is that? So it's actually going to be inversely related to the period. The symbol for frequency is going to be lowercase f. 1 divided by the period, that'll give you your frequency. So if we took just a few scenarios, we'll go through a few extreme scenarios here. When you're spinning something in a circle in lab, you might have observed that, okay, this thing just moving in a circle might have taken a fraction of a second, 0.5 seconds to go by, a period of 0.5 seconds. You can have something maybe a little bit slower, something like 2 seconds. Probably didn't achieve that in lab, but it's easily possible to see something rotate around and take 2 full seconds to do a particular rotation. If we want to talk about another, I would say, different end of the spectrum here, we could think about the planet Earth, the sun, and the fact that the Earth has to rotate around the sun. That takes an extremely long time, 365 days. Now what we want to do is we want to be in seconds. So essentially, if we multiply 365 times 24 times 60 times 60, that should get us the amount of seconds in a year. So this would be best measured in seconds. We'll report it in scientific notation. I'll just say 3.15 times 10 to the 7 seconds. That is an extremely long amount of time. And then you could think about something really that spins really quick. All right, so what comes to my mind is probably something a lot of you guys use throughout the day. A blender. Now, I actually have no idea how fast these things move. We had someone look it up, but actually let me look up the speed of a blender in RPMs. Maybe I think that'll give us a good idea. So they're saying about 24,000 RPM. So if I do 60 seconds divided by that, this is an extremely high powered blender. I'm not quite buying these values, but I'll go with it. 0.0025 seconds. When you hit that button on the blender, it spins very, very rapidly. So a small fraction of a second. So you have something that's really slow, something that, two things that are at moderate speed, and then this thing is extremely fast. And if we wanted to look at frequency values, we could do that here. So if we're thinking about frequency, for this object right here with a period of 0.5 seconds, be 1 over 0.5 seconds. That gives me a frequency of 2 inverse seconds. Now an inverse second is something we call a hertz. So we could also call it 2 hertz. That's our frequency there. And what that means is that this thing will move around twice in 1 second. The thing that was going a little bit slower, a period of 2 seconds, if you look here, you get 1 divided by 2 seconds. That gives us a frequency of 0.5 hertz. So this thing doesn't do a full rotation in a second. What it does is it does a half a rotation in a second. On to our really fast thing, we're going to get a really high frequency here. 1 divided by that is going to give me 400 hertz. So supposedly this thing will spin around 400 times in a second. I don't own a Ninja blender, so I couldn't tell you. I can tell you that my personal blender probably is a lot slower than that. But you can see that this is happening a lot more often than something like these two things here. And then when you get to something like this, you're on the complete opposite end of the spectrum. If I do 1 divided by the amount of seconds in a year, I get a frequency of 3.17 times 10 to the negative 8 hertz. So we get a very small fraction of a rotation in a second. So you have the full spectrum of possibilities here in terms of period and frequency.